their parts. Today, we're going to talk about secants and tangents, how to find the lengths of those. So first diagram, I'm going to start calling on people right away here. First diagram, what's ADE and ABC called? We went over those two types, or that type before quiz 2. ADE and ABC. Little review, those two are called what here? 7, I know this by now, Drew? Secants, good job. And then we go over here. BCD is a secant, but what do we call AB? That's not a secant, that is a Finley? Tangent. All right, so that's what we're going to find the lengths of, tangents and secants. Yep, and you can take it right out there again. All right, tangents and secants. Good? All right, what I have is a saying for you. Okay, I have a saying. It's not a little formula, it's a saying. So let's start this off. To find lengths of tangents and secants. And it's a saying. It's not a formula, it's a saying. And here's how we do it. Whole times external. Anybody want to associate another word with external? Outside, right? Whole times external equals whole times external. That is how we're going to find the lengths of all these tangents and secants, by using this phrase. Whole times external equals whole times external. Can you go back up to my first diagram? Because I actually want to show you what this means here before we put numbers on the diagrams. You guys told me that these were two secants. Name a whole secant for me, please. Name one whole secant in that diagram using the letters. Name a whole secant up there. Jonathan? A whole secant. Just name one.
AC.
AC. All right, so what I would do here is AC, whole secant, times its external part. The part of that AC, part of AC on the outside. Name it. So AC, that secant, what's the part on the outside going to be? Lily? Good job. So I would do AC times AB. Set that equal to, now go to the other secant. Give me the name of the other whole secant now. The other whole secant. Cormac? D, what is it? EA, good. Times its external part, which would be, for secant EA, the external part, Vinny? DA, good. So everyone see how that works for that one. Whole times external equals whole times external. Now go to the second diagram. You guys told me that was a tangent. Watch how this works. It works the same way. Just you'll notice something. Go to the secant first. Name the whole secant. Whole secant's name? Finley? DB. Good. So I'm going to go DB times its external part, which would be, name it. DB's external part. Lily? CB. Good. Now watch what happens when you go to the tangent. Whole tangent, AB. What's its external part? Also, AB. So when we're doing whole times external for a tangent, it's the same value because the whole tangent is on the outside. All right, so that value is going to be the same every time for a tangent. All right, there it is. Now we're just going to get reps. Whole times external equals whole times external. Before we start number 1, let me show you my one big worry, especially after we did yesterday. My one big worry, look at number 1. You guys are going to do 5 times 10 equals 4 times x. That was for chords. Chords. These are what here? Secants. All right? So it's not part times part anymore. That was for chords. Chords. We're doing secants. So now we got to do whole times external. So look in here. Give me one whole secant length now. One whole secant length. Stephanie, one whole secant length for me. 15. Good. So one whole secant length is 15 times its external part. So what part is on the outside there? Lily? 5. So 15 times 5. Whole times external. Keep going now. Be careful. Give me the whole secant on the other side now. What's the other whole secant over there? Finley, back to you. We're just bouncing back and forth. There you go. Perfect. I got OCD, so I'm going to put my X first. X plus 4. And then what about the part on the outside, the external part? Sure, I'll just keep looking at this like an idiot. There we go. Alexi in the bottom corner. Part on the outside, external part. 4. Done. There it is. Everyone to see the whole times external being applied. All right, go ahead. Now it's just calculations. There's rounding directions at the top, all right, because it's not going to be a whole number here. So I've got some rounding directions for you. All right, everyone solid with 14.8. All right, let's move to number 2 then. Now I have a secant and a tangent. Still whole times external. Give me the whole secant length first. Please, whole secant length. Stephanie? 11, good work. 11, and then how about the part on the outside, the external part? Who, Drew? 2, yep. All right, now go to the tangent. We talked whole and external for a tangent is the same value, y. So y times, y. So we got 22. If anybody's putting 2y here, leave the room immediately. You're an embarrassment to the math community. All right, that's not 2y, y squared. And go ahead, take the square root on both sides. I'm getting a little 4.7 here, huh? 4.7. All right, again, 3. Don't get in the part times part habit. This is 2 secants, so I got to do whole times external. All right, got to combine some like terms here sooner or later, but give me one whole secant, either one whole secant length. Bryson, one whole secant length. All right, looks good to me. And how about the part on the outside of that secant? Part on the outside. Zoli? 8. All right, now you got to combine some like terms for that other secant. What's the whole length of the other secant? Drew?
Which one?
The one we haven't done.
Y plus 3. Y plus 10.
Y10, because you had to add in the 7, right?
Mm-hmm.
All right, good. And how about the part on the outside of that one? Shara? 7. There you go. Little distribution, and you're on your way. We're moving right along here. So make sure we're getting 6. Okay, and before we get to this next one, everyone comfortable with this whole times external idea? Any questions? Because what I want to do now here with number 4 is put yesterday with chords and today with tangents and secants all in one problem. All right, so we got to go back to yesterday and remember that fact that I gave you. First, let me do something that's going to be incorrect, and I'm going to end up erasing it. So I just need your attention. That's it. Don't write anything down. Let's say we wanted to solve for y. What is y here? That's a what? That's a tangent, right? Everyone agrees? So I'd probably do whole times external. Watch what happens when I do whole times external. I do y times y. Does everybody see the secant in this diagram? Everyone see the secant? I'll highlight it right here in green. Now, when I ask somebody for the whole secant, they're going to have what variable in it? Right? They're going to have an x in there. That's not going to work. Because I have y on this side, I'm going to have x on this side. That's not going to work. So there's no way I'm going to be able to do whole times external right away. All right, so I can't do that. So we have a tangent in there. We have a secant. Anybody see any other parts of a circle we've talked about before in that diagram? I got a secant. I got a tangent. It's not going to work because I'm going to have an x and a y on both sides. Anybody see any other different parts that we've talked about specifically yesterday? Chords. Everyone see 2 chords? And are they intersecting? Yeah, perfect. This is yesterday's discussion. Chord NM and chord RP are intersecting each other. So the product of their parts are equal. That's where we're going to start by solving for x. So I need somebody to take one of those chords, either NM and RP, and tell me the 2 parts of it. Take one chord and tell me the 2 parts so I can multiply them. Jared, give me 2 parts of one chord.
10, 3.2.
So I'm going to, from yesterday, I'm going to go 10 times 3.2 is the same value as, to go to the other chord now and give me the 2 parts. Jared again, 2 parts of the other chord.
4 and
There you go. So this is where I have to start, is by doing the chords. Grinding away here. We get 8 for x. All right, you are going to have to substitute it back in that diagram. So you can tell me the whole secant length, so I can do whole times external to find y now. All right, so now we're going to go tangent secant and do whole times external. So I already know it's going to be y times y, whole times external tangent. All right, now I need somebody to tell me what the whole secant length is now. Substitute 8 in for x. The whole secant, not the whole chord. I need the whole secant here. Whole secant length. Dylan, whole secant length. 18. Everyone see where he's getting 18? 4 plus 8 plus the 6 on the outside. 18. And how about the external part of that secant? Its length. We're going back here. Bryson, outside part of that secant? 6. There you guys go. Great problem. Using both days. What do you got there? 108? Yeah. And I do ask, I know your calculator's giving you simplest radical form, but we'll keep with the directions nearest 10th, 10.4. Whew. Any comments, questions, concerns? All right, buckle up for this next one. Buckle up. Doesn't look like much. All right, and the geometry isn't much either, but when we get to the algebra part, buckle up. All right, tangent secant. Right, tangent secant. So I'll do the tangent, whole times external, 10 times 10. All right, combine some like terms for me. What's that whole secant length? That whole secant has a length of... Yeah, I do this every time. Lily. 2x plus 4, thanks. Worth the wait right there. And then its external part. External part, Jared.
X.
X, thanks. All right, no problem, kids, right? No issue on the setup. All right, let's go to the algebra. I got 100 on this side. 100 on this side. On the other side, we're going to distribute, aren't we? Distribute the X. X times 2X. 2X. Okay, good. Whew. Always get nervous. Plus 8X. All right, here's where the fun begins, huh? Here's where the fun begins. I don't know why it would be, because I'm an embarrassment to the math community. That's why I should leave. What's the deal now? No square rooting, right? Because it's got an x squared and an x. We did this yesterday. We ran into this problem yesterday when we had an x squared and an x. What's going to end up happening here? Yeah, factoring, but we know what? No factoring unless equal to 0. So let's move that 100 over. What do you say? So 0 equals 2x squared plus 4x minus 100. Now I got breaking news. I have not asked you to factor anything like this all year. The only thing we have factored in this class is when that number in front of the x squared is 1. That's the only thing I've asked you to factor. Suggestions? What's up, Dylan? What's good?
Did you go back a step and just divide it by 2 to get
How about we just stay on this step and divide everything by 2?
Okay.
Is that all right with you? All right. Yeah. Why don't we just divide everything by 2 so that now you can only do that if you're going to divide you can't just pick and choose what you divide by 2. You do have to divide everything up there by 2, including the 0. But is that going to affect it? 0 divided by 2? It's still 0. Yep. So if you divide by a number, in this case 2, you got to divide by everything. So divide by 2, we get x squared. Divide by 2, we get 2x. Divide by 2, we get negative 50. All right. Now we've been down this road a lot this year. Two numbers that do what? Multiply to negative 50, the last one, but add to 2. I'll wait. Two numbers that multiply to negative 50, but add to 2. Waiting for these numbers. "22 minutes left in class. Still waiting. It's only going to get more annoying.
Is it negative 1 plus or minus radical 51?
Anybody find any numbers? Good, because they don't exist, right? What do you got? 2 and 25? They're not going to give you 2. What, 10 and 50? They're not going to give you 2. All right, well, I'm not saying there's not an answer. I'm saying there's no numbers to factor. So we got to go to our old reliable then. No matter if you can factor or not, what can you always, I know we haven't used it in a couple units, What can we always rely on, though, to find an answer to this quadratic? Anything with the squared. You can't factor. That doesn't mean there's no solution, though. What can I always rely on, though? Anybody? Anybody? What was that? What was that? Quadratic formula. Yes. On a Wednesday, second period. Yes. Quadratic formula. I'm doing this with you because I think you have to rely on it tonight for your assignment, so you're not going to skip it. Quadratic formula. Anybody want to throw it out there? Come on. Come on. Show off. Show off. Quadratic formula. I'll start you. X equals. There is a square root involved. Let's go. Build this sucker together, right? Build this together. There is a square root involved. Anything else you want to throw out that you think might be involved? Oh, there is a plus or minus involved. There is a 2a on the bottom. Starts it up. Look at this. Like one big village here building this.
Is there AC inside of the square root?
There is an AC in there. Yes. Ah. 4AC. We're missing one more part here. Yeah, there we go. All right, we finally did it. That was painful, but we finally did it. All right, because now that you guys have these calculators, once you substitute in for A, B, and C, you can type it all in one spot in your calculator. Oh, here we go. Ready? What's my B value up here? I got 3 numbers up here. 1, 2, and negative 50. Which one's my B value? 2. So watch. Negative. Anytime you plug a number in, make sure it goes in parentheses on your paper and in your calculator. Negative B, plus or minus. Square root, you already told me 2 was the B value. So 2 in parentheses squared minus 4. What's my A value? The number in front of x squared. What's the number? 1. How about your C value? Negative 50. All over, all over, not just your radical. Make sure that it's not in your calculator. All over 2 times the A value, 1. Again, hey, your calculator doesn't have a plus or minus button on it. So you're going to have to do this calculation twice on your calculator. 1 using the plus, 1 using the minus. And then check out the rounding directions again. Round to the nearest tenth. Round to the nearest tenth. Not simplest radical form. Nearest tenth. So make sure you do it twice. 1 with the plus and 1 with the minus. And the other thing to make sure you watch out for, make sure it's all over 2 times 1, just not the radical. All over 2 times 1. All right, let's see if we got them. As you figure out here, because once we find the answers, I'm still not done with the problem. Here, the positive answer I got was 6.1. 6.1, the positive. And then you also got a negative answer, negative 8.1. So make sure we're not user error on our calculator. It's not your calculator's fault, it's yours. Trust me. And now we're just going to have an awkward staring contest till somebody tells me what the deal is here. Not ready to go on to the next problem. You should know why. We've covered this a ton in this year, covered it a ton. I do not like what's up on the board right now. Do not like it. Bailey, why not?
We have to reject the negative answer.
Why negative 8.1? Why won't it work?
Because we have a diagram, you can't have a negative sign, right?
Yeah, AC can't be negative 8.1 units, right? Everyone knows that. So let's reject that sucker. And we can keep 6.1. Good work, everyone. Good work. And you are on number 5 all by yourself. And remember, whole times external. Whole times external. Making sure we're doing whole times external, not whole times internal. So 4.5 should not be used in your equation. All right, that's on the inside. I needed to find the outside, so you subtract the 2, and it should have been 8. All right, it should have been 8 on the outside for the external part. X squared equals 100. Should get 10 for dA. 10 for dA. Okay. All right, you guys got plenty of time here today. Do not skip over the quadratic. If you need to use quadratic formula, you know it now. It's in your notes.